The graph of an exponential function. So we're going to strip down the general form of our exponential function and call the parent exponential function just f of x equals a to the x. And we'll worry about what c does through our transformations. So remember, the base a is strictly greater than 0 but cannot be equal to 1 to be an exponential function. So the key points, or what I like to call the anchor points, will be -1, 1 over a, 0 and 1, and 1 and a. And that's because the inputs, if we put in -1, a to the -1 power is 1 over a. The next input of 0, a to the 0 power is 1. And the next input of 1, if we take a to the first degree, that's a. So we'll call these shapes ramps. There is a horizontal asymptote of y equals 0. In other words, the x-axis is an asymptote for the parent exponential function. There is a single y-intercept of 1, so the coordinates are 0, 1. The domain is all real numbers, and the range, because it lies above the horizontal asymptote of y equals 0, it's from 0 to infinity. Now we need to consider two cases for a. Either a is strictly greater than 1, or a is strictly between 0 and 1. So when a is strictly greater than 1, we have an increasing ramp. We have exponential growth. And when a is between 0 and 1, in other words, it's a fraction between 0 and 1, we have a decreasing ramp, and we sometimes call that exponential decay. So an example here for an increasing exponential function would be f of x equals 3 to the x, and f of x equals 1/2 to the x would be a decreasing, in other words, exponential decay. But the graphs I'm showing first are just showing you how we increase exponentially if a is strictly greater than 1 on the left, and we decrease exponentially if a is between 0 and 1 on the right. Now specifically, the two examples I mentioned, let's identify a and then go ahead and make a table of values, 3 points for each, and then sketch the graph. So for f of x equals 3 to the x, a is 3. So for the x value of -1, we would have 1 over a as the output because 3 to the -1 power is 1/3. For 0, 3 to the 0 is 1. And for 1, 3 to the first power is 3. And sketching this graph, remember we'll sketch in our horizontal asymptote of y equals 0. And we'll use these 3 points and connect them as a smooth curve, so this will ramp up. So we'll have -1, 1/3 is maybe about here. And then 0, 1 would be about there. And then 1, 3 might be up here, about 1, 3. And then we would sketch the shape of the exponential function. And then for f of x equals 1/2 to the x, a is 1/2. That's a number between 0 and 1. So for our input of -1 for x, we'll take 1/2 to the -1 power, so that becomes an output of 2. For 0, anything to the 0 power is still 1. And then for 1, we take 1/2 to the first power, so we'll just have 1/2. So we'll sketch this first by putting in our horizontal asymptote of y equals 0. And let's say -1, 2 is about here. And of course 0, 1 is in exactly the same place as it was in the other graph. And then we have 1, 1/2, maybe about there. And then we'll sketch the general shape of a decreasing ramp to sketch that graph.